Welcome back to the First 50. We're at lesson 38, and today Tom finally gets to pull the trigger on that runaway Chrome process. 2 lessons ago, he tracked down a crypto miner hiding in a Chrome tab, PID 4231, burning 87% of his CPU. Closing all of Chrome would nuke his other tabs. Rebooting is overkill. What he needs is precision, and that's exactly what kill gives him. 4 letters, 1 PID, and the process is gone. Now here's the twist in the name. Kill doesn't actually kill anything. It sends a signal, and the process decides how to react. By default, that signal is SIGTERM number 15, a polite tap on the shoulder that says, "Please shut down nicely." The program saves its work, closes its files, and exits cleanly. When that's ignored, you escalate to SIGKILL, signal 9. The kernel yanks the plug, no cleanup, no negotiation. And there's a third one worth knowing, SIUP, signal 1, which tells daemons like nginx or SSHD to reread their config without restarting. Polite first, force only as a last resort. So let's watch Tom put this into practice on his Chrome miner. Step 1, he confirms the PID with PS. There it is, process 4231, burning through 87% CPU. Step 2, a plain kill 4231, no flag, so it's the polite SIGTERM. Notice the terminal says nothing back. That's not a bug. That's Unix being Unix. No news is good news. Step 3, he runs PS again to verify, and only the grep itself shows up. The miner is gone. Diagnose, monitor, fix. The full-stage Arrow 8 workflow closed out cleanly. But what happens when the process doesn't cooperate? Some processes are hung, broken, or actively ignoring you, and SIGTERM is, by design, ignorable. That's where kill 9 comes in. Signal 9, SIGKILL, goes straight to the kernel, which terminates the process on the spot. No cleanup, no saving, no goodbye. Files may be left corrupted, locks may stay stuck, and dependent services get no warning. So the rule is simple. Always try plain kill first, wait about 5 seconds, and only escalate to 9 if the process is genuinely refusing to die. Now here's something that would have saved Tom a few minutes earlier. Kill isn't the only tool in this family. It needs a PID, which means hunting through PS or top first. But pkill and killall work by name. Pkill Firefox takes out every Firefox process matching that pattern, and killall Chrome does the same by exact command name. And the best part? The escalation rules carry over. Kill 9 or killall 9 behave exactly like kill 9. Same SIGKILL, same caveats. Polite first, forceful only if you must. So let's pull it all together with Tom's actual session. Step 1. PS surfaces the culprit. PID 4231 chewing 87% CPU talking to a mining pool. Step 2, top P4231 watches that single process for 30 seconds, and it stays pinned at 85 to 90%. Not a spike, a squatter. Step 3, a plain kill 4231, then a quick PSP 4231 to verify. Gone. The fan winds down, the battery stops bleeding. Diagnose, monitor, fix. That's stage Arrow 8 in 3 commands. Now, a word of warning before you get too comfortable. There's a temptation, especially early on, to reach straight for kill 9 because it sounds decisive. Don't. The -9 skips the program's cleanup entirely. No saving, no closing files, no syncing to disk. Run it on a database and you get corrupted tables. On an editor, lost work. The rule is simple. Plain kill first, wait 5 seconds, and only escalate to 9 if the process refuses to budge. Polite door knock before you kick it in. Here's where kill fits into the bigger picture. By itself, kill is just the action. It needs a target, and that's where its 3 sister tools come in. Piece from lesson 36 finds the PID with a quick aux pipe grep. Top from lesson 37 catches the troublemakers live, and you can even press K right inside it. And pgrep, the bonus, is like grep built for PIDs. Clean enough that you can pipe it straight in, as in kill $parent pgrep Firefox. Find, watch, or look up, then act. Now it's your turn. 3 safe little drills, no real processes at risk. First, run sleep 1000 in the background, find it with pso pipegrep sleep, and kill its PID. That's the basic loop. Second, launch yes redirected to jux dev null. It'll spin a CPU core happily forever, so try a polite kill first, then fall back to -9 if it ignores you. And third, start 2 sleeps and take them both out by name with kill sleep. No PIDs, just pattern matching. Play in the lab before you need it for real. And that's lesson 38 in the bag. You can now see processes with Ps, watch them with top, and control them with kill. CPU and memory misbehaving? That's your problem to solve now. Next up, we shift from processes to storage. DF, the disk-free overview, the answer to why is everything suddenly failing when a drive quietly fills up. See you in lesson 39.